Okay, let's move on to the next test. We're in the business of making aces work. Let's go ahead and extend this test. I'm just going to make this test all about aces, so we're testing aces. So now we want to know that, oh, maybe that's a bad idea. Well, let's see if it's a bad idea. If it is, we'll change it. All right, so we're going to test that 2 aces is 12. Now, that has to follow this one. This is a bad idea. Okay. The reason I'm finding that's a bad idea is because I'm going to need a test that looks like this instead of this, because we have a multi-card issue and we don't have a nice method to do that yet, of course. All right, so what we're going to do is create a whole new test method, and it's going to be based on this one, multi-cards, because it is multi-card. And we're going to testing AA is 12. You notice I don't get real creative about my test names until a little later when I know what I'm really doing. Okay, so 2 aces should be a 12. Remember, that's because at least one of them needs to get converted to a 1 in order to keep the hand under 21. It tries to keep the hand under 21. Okay, let's make sure it fails. Yep, commit it. So easy. All right, ace should be 12. Yep, there, okay, but it was 22, look at that. All right. All right, how do we get there? Well, the problem is that aces need to be counted as a 1 sometimes. So that means sometimes in aces until 11, it's a 1. And this is where that value is coming out for an ace. But how do I know when to convert it to a 1? Well, I would need to know what the total value of the hand is currently. Because if it's over 21, then I need to convert it to 1. That information isn't in this method, and it's not part of my state of my object. I could make it that. That's one way to go. Or I could do the adjustment for the aces up in the evaluation, because this is where total is. That's where I know if I'm busted or not. I kind of like putting it up here for now because I have direct access to this total right now. So why don't we do this? Why don't we let the hand total out and then decide if we're busted. So if total is greater than 21, we're busted. In which case, I need to reduce an ace. But now I've got a new problem. How do I know I have an ace? That's encapsulated inside here. So I've got a couple choices. I either need to make total available in evaluate card so we can change the meaning of an ace from 11 to 1, or I need to somehow remember that I've seen an ace and make that available to evaluate. I have a choice. I can pick one way or the other. I'm going to choose to mark the fact that I've seen an ace and make its value 11 initially, and then if I'm over, I will adjust down. That's my choice. All right. So that means I need an instance variable. So it's going to have a side effect. Ooh. All right. Well, we'll think about that later. So private int aces. This will keep track of how many aces. It'll start off at 0. And here, if I've seen an ace, I just increment it. Well, let's see, plus. Okay. All right. Now that I got aces counted, now I can refer to it here. So here's the trick then. I need to know, okay, so I only do this if I'm busted. So if the total is greater than 21, I do this outside the loop. So I add up the whole hand first. Now, if total is greater than 21, what am I going to do? Well, I need to know if I have an ace. So if aces is greater than 0, then I can take the total and minus equal, subtract off. You could do subtract off the 11 and then add in a 1, right? Because an ace is 11, so I'm subtracting off the ace and then I'm making it a 1, adding it back in. Or I can recognize that the difference is just 10 and just subtract 10. So I'm subtracting off 10 of the points of the 11, leaving it as a 1. All right, there we go. I like it. How does that work now? Okay, so what if it's not, if aces, well, I don't want to think about it. All right, let's just save it and see if we pass the test. See, I was getting too much into design. The goal is to get to green quick. All right, looks like it worked. Passing, we passed AAis12. Yay! Cool. Cleanup. Well, we have this, and we could probably collapse this and say if it's total, that and aces is greater than 0. Both have to be true to do this part. So I like that. That looks, it's simpler logic. I don't have nested ifs anymore. Let's see if that passes. Sure enough. Okay. Pretty good. That's pretty clean as far as I can do right now. Over here. Okay, now I definitely have duplication between multiple cards test and AA test. We should spend some time and clean that up. So what we need is, just like we had a assert card as value, we should have assert cards as value. Why don't we do hand as value so that we know hand is made up of multiple cards. So let's try that. How are we going to get there? Well, first thing, as we did before, let me put these two methods close to each other because I need to make them look alike and keep the test passing. So I just moved it. That shouldn't cause any problems. Waiting for the test. There it is. All right, no problems. Now, let's take out the things that are different and put them into variables. So I have two cards. Well, I know I'm headed for a hand, and a hand is an array of cards, so let's do it that way. 7 and 10. And then I can replace this 7 with hand of 0, and this 10 as a hand of 1. Cool. And the value, well, I need a variable for that. Well, let's make sure this still compiles and runs. Baby steps, baby steps. Sure does. All right. So now let's get this 17 out of there. So the value of that hand is 17. Replace 17 with that. Save it. Perfect. Now we basically want to turn this method into the same thing. So we're going to pull the aces and the 12 out. So we're going to have two aces. And 12 is going to come out. That shouldn't cause any problems yet. Did it already? No, okay, there it goes. All right. No problems yet. Now let's go ahead and replace actually, I'm going to replace all this code with this code because they should be the same now. All that's changing is the data, the input to it, which tells me I've got a function. All right, let's turn that into a function. Now, at this point, it's about 2 cards, you'll notice, but let's not worry about that yet. We will generalize that in a second. We can do that in one method later. So let's see, void assert hand value, hand is value. Okay, and then I got a char array which represents the hand, and I'm going to pass a value as the second parameter. compile, let that run. I just saved it, it will catch that. So while it's working on that, I'll move on to the next thing. And I basically just want to move all this down in there. Okay, and now I need to make the call. Assert hand is value. Pass the hand and the value. Check it out. That's from the last. Now I'm going to save it and check for this test because I really want to know that this works. And it does. Awesome. Oops, too far. Okay, that worked nicely. Now I want to do the same thing up here. So let's replace this code with that code. Nice. And it works. Okay. Now I could inline this like before, and I probably should. So inlining it requires a little trickery. When you create an array in this as part of the initializer to when you declare the variable at the same time, you get to use this simplified syntax. When we move this down here, we're going to have to say new char array. It's more syntax. We can do that. Oops, that won't come out. Get rid of this. And let's go ahead and change this to 12. Nice. There it goes. Passing. Awesome. And that means I can take this and make the same for here. It's a 7, a 10, and a 17. Clean that up too. Okay, and that's done. Now let's see, where are we? All right. So we have multiple cards. We've removed that duplication. I think I would like to move this down to where the other helpers are. Get it out of the way. Yeah, there we go. I like that better. Now, I will point out that we are only handling 2 cards, a 2-card hand right now, even though we said we're asserting hand full card. All that's going to be is changing this to a loop, but I'm not going to do it yet. I'm lazy. All right, get rid of that. That works, hopefully. All right, we all clean. Testing is, yeah. That all looks good. We're passing our tests. We are clean. Call it clean. All right, now, just a quick note, you'll notice that all the work we do, the real work, tends to be in either writing a test and most of it is in the refactoring and cleaning up our code. That's where we spend our time doing redesigns and all that kind of stuff. All right, anyways, ending this video.